Solving simultaneous equations by elimination. We want to solve the following simultaneous equations by elimination. So let's call this one equation 1 and this one equation 2. Now this one's a particularly simple example because both equations have 2y. This one is a plus 2y, this one is a minus 2y. Now in general, when you've got a letter where there's the same number, so 2y's and 2y's, if the sign in front is the same, you subtract the two equations to get rid of that letter. So same starts with an S, subtract starts with an S. If, as in this case, they're different, we add. Different has a D, add has a D. So what we're going to do to get rid of the y's here is add because the signs are different. So 1 add 2. 5x add 3x gives me 8x. Adding positive 2y and negative 2y means the y's disappear. We have no y's, and that was the point of doing this. It means that we get rid of one of the letters. Then 17 add 7 is 24. So divide both sides by 8 and we find that x is 3. Then to find y you can substitute back to either of the original equations. I'm going to sub into equation 1. So that gives me 5 lots of 3. Add 2y equals 17. So 15 add 2y is 17. So that means that 2y must be equal to 2. So y is equal to 1. And we have x is 3 and y is 1. Now we used equation 1 in order to find that, so we should check that works with equation 2. So 3 lots of 3 and 9. Take away 2 is 7. So it works in equation 2. So this is the solution. Now if we call this equation 1 and this equation 2, note here we don't have the same number of x's, nor do we have the same number of y's. But we can easily change the second equation by multiplying everything by 2. And then it will become 8x add 2y is equal to 10. Let's call that equation 3. And equation 1 and equation 3 does have the same number of y's. Both equations have 2y. This one is a minus 2y, this is a plus 2y. So once again we're in the different add situation. So if we do equation 1 added to equation 3, we get 11 x's. The y's disappear, that was the whole point. And 1 and 10 is 11. So that tells me that x is 1. Let's substitute that into equation, I'm going to go for equation 2. Never go for equation 3, always go for the original equations here. So that's going to give me 4 lots of 1. Add y equals 5. So 4 add y equals 5. Y must also be 1. So we're going to say x is 1, y is 1. We used equation 2. Let's check for equation 1. So that would be 3 take away 2, which is 1. So that's a correct solution. Moving on to this pair of equations here, we can see that we have the same number of x's. They are the same sign as well. Same means subtract, and remember, if the signs are different, we would add. Same, subtract, different, add. So 1x in both equations, and it's a positive 1x. So we have the same sign on the letter that has the same number. So we're going to subtract. Now I'm going to do this as 1 take away 2. So x take away x, that will disappear. Then we have negative 3y take away negative 4y. And that will become negative 3y add 4y, which is positive 1y. So y equals, and then 9 take away 11 is negative 2. So we get to y equals negative 2 straight away. So I'm going to substitute that into equation 1, and then I get x take away 3 lots of negative 2 is equal to 9. So that's x plus 6 equals 9, and therefore x is equal to 3. So our solution is x is 3, y is negative 2, and of course we should take that solution and check it in number 2. So if I had 3 add 8, that would give me 11. So this is a correct solution. If we now look at this example, we don't have the same number of x's, we don't have the same number of y's. Now, I can either multiply equations in order to get the same number of x's or get the same number of y's. Now, in this particular example, I'm going to choose to just multiply one of the equations to get the same number of x's. In order to get the same number of y's, I'd have to multiply both equations. So I have 5x's here and 10x's here. If I just do equation 1 and multiply it by 2, I then get 10x plus 6y is equal to 14. I'm going to call that equation 3. And we've got 10x add 4y is equal to 16. And that is equation 2, which is completely unchanged. Now, I want to get rid of the x's. I have 10 x's in each equation, and they're both positive, so same subtract. I'm going to do equation 3, take away equation 2. So 10x take away 10x, that disappears. Then we've got 6y take away 4y, so that's 2y. 14 take away 16 is negative 2, so y is negative 1. And then let's substitute that into 1, and I get 5x. Now if y is negative 1, that will be take away 3 equals 7. So 5x equals 10, and then x equals 2. So my solution is x is 2, y is negative 1. And of course, we used 1 for that, so we should go back and check it in 2. So that would give me 20, take away 4, and that is 16.